Let's revise the tangent line in this video. So tangent line, and let's do it with an example on a graph. So if we have the function of f of x equals to x cubed minus 4x squared plus 7x plus 3, and we want to find out the tangent line at the point of x equals to 2 and y is going to be f of 2, the result of that value. Okay, let's do it on a graph. Let's draw the xy axis. Xy axis, so let's say it would look something like that. X and y and 0. And let's say the function itself would look something like this. So we would have, sorry about that. So we would have something like that. And we want the tangent line at the value of x equals to 2. So for instance, x takes the value of 2 over here. What is the tangent line? It's literally a line that touches the graph at this point. So that would be it. It barely touches the line. It barely touches the graph. Now, because it is a line, we know that the line has the shape of a mx plus b, where we have the slope and the intercept. What is the first step to find out? The first step, when finding out a tangent line, we look for the slope. So let's calculate the slope. First step, find out our slope. What is our slope? Our slope is a derivative. A derivative of what? Derivative of the function. So we're differentiating our function. Let's go back to our function, which is x cubed minus 4x squared, x cubed minus 4x squared plus 7x plus 3 derivative. So we're differentiating every term separately. X cubed derivative from the power rule, that's just 3x squared, minus 4x squared derivative is 4 times 2x, so that's 8x. 7x derivative is just 7, and 3 derivative is 0, so no need to write it. That's the derivative of the function, that's the general slope, but we need the slope exactly at the point of 2, because that's the question. Well, if we need the slope exactly at the point of 2, we're just going to substitute 2 into our derivative. So we substitute into the derivative the input of 2, and we go here and we write 3 times 2 squared minus 8 times 2 plus 7. So that's 3 times 4 minus 8 times 2, that's 16, plus 7. 12 minus 16, that's minus 4, plus 7 equals to 3. That's the slope that we care about. That's our m. M equals to 3. What's the next step? The next step is to find out our intercept. How can we do that? Well, let's see what we get so far. Because our line, our tangent line, has the shape of mx plus b. Mx plus b. And we just found out our m, so we know that the tangent line has the shape of 3x plus b. How can we find our intercept? Well, to find out intercept, we need to know that the x value, the x at the point of 2, has a corresponding y value, right? We have a value of f of 2 over here. And we need that because the tangent line touches the graph on this point. So if we would substitute the value of x equals to 2 into our tangent line, we would get the result of f of 2. So let's do it. If we have x equals to 2, what is the f of 2? Well, we substitute 2 into our function. So we go all the way over here to our function, and we are going to write 2 to the power of 3 minus 4 times 2 squared plus 7 times 2 plus 3. That's 8 minus 4 times 4, 16 plus 14 plus 3. 8 minus 16 is minus 8, plus 14 is 6, plus 3 is 9. So we know that when the value of x equals to 2, the resulting y value equals to 9. We got that. Now let's substitute this into our next step. Step 4, we're closer to our tangent line, because now we know that for x equals to 2 and the slope has the value of 3, we need to only find out the intercept, which means that 9 equals to 6 plus our intercept, which means that our intercept equals to 3. And as our final step, we can write the form of the tangent line in a general way, which is the tangent line has the intercept of 3 plus the slope of 3 times x. And that's it. We are done.